Hey everyone, welcome back to my daily coding series. Today is day 96. I was just looking through some more problems today, and I'm gonna try a backtracking problem because I haven't done one of those in a while. Okay, so I'm given two integers n and k. Return all possible combinations of k chosen from the range 1 to n. And we can do it in any order. So if we look here at the example, n is 3 and k is 2. So all possible combinations of two numbers from 1 to 3. So we have 1, 2, 1, 3, and 2, 3. If we have three numbers of size 3, okay, then it's 1, 2, and 3 is the only possible combination. Right. Okay. So I think so if we have, let's say, n numbers, at every number we either can include it or skip it. So we can include 1, include 2, skip 3. We can skip 1, include 2, include 3. Whoops, sorry, that should be 2, 3. Or we can include, skip, include. We could also do skip, skip, skip. Or we could do include, 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 right? But we have to check this against k. So a simple approach to it, I guess, would be, so we'll take in the index that we're at, and then like our combination so far. And maybe this will return none. So I'm thinking we could have like a result array, and then this will append results. So basically what we want to do is either include it or not. So if we don't include it, then we'll just pass in. So what is combo? Combo can be probably, so it's a list of lists, so we could send a copy of combo to so okay, wait, there's a better way to do this. So if we include the new number, we could say combo dot append I plus 1. All right, so this is a little confusing. So I plus 1 is the value itself because it just goes 1, 2, 3. So if we want to include the first number, that would be 1, for instance. Then yeah, so then we'll pass, then we'll remove it. Yeah, so we'll call this function with it and without it, and then at every time we'll have the base case. First of all, if I is greater than n, then we should get out and something like if I is greater than k, then we should append combo and this might not need copy. This one definitely does. Because I know if we don't copy it, then it just sends the reference, which with the order that we're processing it, it may be fine just like this, but okay. Right, okay, so if combo is greater than k, and we want length of combo. if the length of combo is greater than k, so that would be, for instance, or maybe equal to. Yeah, I think when it's equal to k, but we'll put greater than for good measure, but, or maybe we should be more precise. So when it equals, so if we have a combo of size 2, then that's a possible result. And if we're done, like, this means that there's no more numbers to pick between. So for instance, if we skip all of them, it should get caught by this return statement here, and we just don't add it to our result. Okay, let me see what result looks like, and for now I'll just return empty list. Alright, so I outputted nothing. Let me print see what I and combo is. Oh, I'm never calling the function. That'll do it. So we want to pass it with I equals 0. I mean, we could just pass it with I equals 1. And then we don't have to do the I plus 1 thing. Yeah, I'll do that. So we start with I equals 1, and combo starts as empty list. So let's see what that does. Okay, so here we have the expected output. I also want to see from my own curiosity what happens if I just pass combo. If it's the same thing. Yeah, it is. But this one, it's not, right? Because we want to just store this and not use it, whereas this, based on the way that we're doing it, it's going to be the same list the whole time. Yeah, because now the reference points to this one, so now they're all empty list. So we do have to append a copy of that combo. Alright, so let me try. I'll just return the results and see what that gives me here. Am I printing? That's probably... Let me try again without the print statement. Okay. Yeah, so that's a pretty standard approach. So let me see if... So I think you have to... Maybe you don't have to do it this way. But I think you do, just because at every point you have to make that decision. We could do some trimming. So for instance, if we skip I was thinking, like, if we skip, there is something that you can do if you keep track of the number of skips as well. So here you did not skip, so skips goes by, and then here you pass skips plus 1. So now we know how many times that we've skipped. So I mean, you could say, like, if skips is greater than k minus n or something like that. So we know that we can skip only, so k is the length of our output. So maybe it's n minus k or something. Alright, so n is how many numbers we have. So let's say we have 7 numbers and we want 5. If we skip more than 2 times, then we know that this will not be correct. So I think it's n minus k. So if we have 7 numbers and if we need 5 of them and we skip more than that amount, then we should return, and we don't need this variation. So I think that will hopefully not make it incorrect. I didn't pass skips, so we start with 0 skips. So okay, that hopefully, the slower solution also passed, but theoretically that should help. Is there anything else I can think of? And yeah, this isn't really necessary, but it might make it run a little faster. Okay. So if we look at LeetCode here, and this one is called combinations. So I like to just try it on LeetCode as well. Yeah, I mean, it is a medium problem because I guess it does require some understanding of recursion, but once you kind of know the formula for backtracking, it becomes a lot easier. And this also gives me like a time metric, so I can compare how fast it is. Okay, so it beats 90%. I'm going to do it again for reliability because sometimes it varies. Okay, so pretty consistent. Now I'm going to try getting rid of this and see how much of an impact that has on the result, if any. I predict that it will be slower now because we will have to calculate those. Yeah. Interesting. So this if statement here does do a lot of trimming. It's basically still like a complete search, but you're trimming out some implausible cases. Yeah, so that's pretty cool. This actually does make a big difference. I'll have to keep that in mind when I do backtracking problems, is like what other assumptions, or I guess how can I use the state of this recursive call to identify whether or not it's valid to continue. And if we just keep track of the number of skips, then we have this little indication there. But anyway, that's today's video. That was episode 96. So thank you guys for watching. I'll be back tomorrow.